here we are for week 5, day 3. This is Mrs. Severs again, and here today we're going to be talking about solving multi-step equations with SOL 8.17. Let's go ahead and go over our homework from yesterday. Here's that first problem with its solution.
So today what we're going to do is model algebraic equations using algebra tiles. We were given the equation 4x plus 4 minus 2x equals 8. I have gone ahead and drawn the actual representations for the key that we're going to use, as well as what the equation will look like. So let's go through both of those so that we can cut some time with actually solving it. So when we look at this question, I use an empty rectangular box to represent my positive x variable. I used a filled-in box to represent my negative x, a brown one for the negative x. The small green empty box is my positive 1, and the shaded in green box represents my negative 1. So with that being said, I'm supposed to represent 4 of my x's. So I found out from my key what the x tile looked like, and I drew 4 of those. Then it says plus 4. So I know that I was not drawing 4 variables, but 4 of my constants. So I needed to draw 4 of the green boxes. Next, I have negative 2x's. So I have to find the negative 2x from my key, the negative x from my key, and draw 2 of those. And then it was all supposed to be equal to 8. So then I'm supposed to draw 8 of my single 1 unit boxes. Now we're ready to solve. The first thing we need to do is to actually combine like terms. So I've noticed that on my left side, I have a 4x and a negative 2x. Those need to be combined together. The 4 and the 8 are actually go together because they are constants, but they will be brought together when we simplify the equation. Okay? So with that being said, let's talk about how we can combine this 4x and this 2x. So you have 4x minus 2x, which means we are actually subtracting. And we know when we subtract 4 minus 2, we get 2. So what that looks like is if for every negative x that I can take away from this side, I have to also take away a positive. There's another negative, so I'm going to take away another positive. Okay? Then I have to redraw my units that I have accidentally erased. So now, once you simplify that first step, you are left with 2x plus 4. All of this is equal to positive 8. Okay? Now we're ready for our next step. We have combined our constants with variables. We now need to combine our constants. And we see that we need to move the 4 from the left side to the right side because we are trying to still isolate our variable to find out what our x value is. So with that being said, we need to form 0 pairs, and whatever we do to one side, we must do to the other. So for this one, we have a positive 4, so we need to actually draw 4 negative boxes on the left, and this is 4 negative boxes on the right. Okay? So when we form 0 pairs, that means for every negative, we take away a positive. For every negative, take away a positive, until everything on this left side should have gone away. And then on the right side, we're forming the same positive, negative 0 pairs. So now we are left with 2x equals 4. So now what I have to do is to actually figure out what do I do with this 2x to make it equal to this 4. I am trying to figure out what x units would look like for this large quantity. We see that this is actually multiplication, so we're doing the opposite of it. We have to divide these boxes to determine how can we get 4 units. So with that being said, in order for you to get 4, we see that you have to divide each one of these in half, and you will get 4 single units. So with that being said, you're dividing 2 on both sides. So that means each one of these x boxes, so we're going to have 2. You need to divide each one of your x's by 2 to get 4 of your single.
And looking at example or problem 2 from yesterday, here is your solution for that.
Go over example number 2 for day 2. I have simply copied over the question, including the key, from the homework practice slide. Just to review, the empty box, the empty small box represents 1 unit. The shaded in empty small white box represents -1. The longer rectangular shaped empty box is x, and the shaded in longer box is -x. So now what we do is use our key to actually write the multi-step linear equation that represents this model. We were also asked to solve and confirm our solution. So let's get started. We notice that we have 2 of the longer shaded boxes, and they represent -x. We have 2 of them. So that leads us to have -2x. We have 8 of these smaller boxes that are not shaded in, which represents a 1's unit. So that gives us +8, because they are positive and there's 8 of those, equals, and now we have 4 of the long empty boxes, which represent x. So we have 4 of those, so 4 times x. And then we have 10 of these smaller shaded in boxes, which represent -1. So that gives us -10. So that answers the first part, which is to write the multi-step equation. Then we are to solve it, which means we need to combine our like terms. And so what I'm going to do is to have you to, first of all, combine all of the terms that have a variable and coefficient with them. So if you look in this one, we have the -2x on this side, and then we have the +4x on the right side. On the left side, we have a constant of an 8 and the -10. So what I want to do is to get all of my coefficients with variables on one side and then all of my constants on the other side. So what I want to do is to try to keep my variables on my left side. It doesn't matter whether you have them on the left or the right. So with that being said, I want to move this. Doesn't matter if I move the constant in the variable first or the coefficient in the variable first, or if I move the constant. It doesn't matter which order, as long as they're changing sides and you get all of the coefficients with variables on one side and your constants on the other. So with that being said, I am going to subtract 4x from both sides because I want to bring all of my coefficients with variables to my left side. Okay. With that being said, this forms a 0 pair, so this cancels out. On my right-hand side, I'm left with -10. On my left-hand side, I have -2x minus 4x, which actually gives me -6x plus 8. Okay? So now that I have that, I noticed that I needed to bring my constants to my right-hand side. So that means whatever constant is to the left has to go to the other side, and you do whatever the operation, the opposite of whatever the operation is. So this says +8. I'm going to subtract 8 from both sides. Okay, so this cancels out. I'm left with -6x is equal to -10 minus 8 gives me -18. Okay. Now I still have to isolate my variable. This operation with them together is multiplication, so I do the opposite of what's there, which means I divide both sides by my coefficient, which means I'm dividing both sides by -6. Therefore, x, I'm dividing 2 negatives, so that means it's going to form a positive, and the number is going to be 3. Okay? Now, with that being said, the last part of the question says to actually verify your answer. Let's get to it. We have 2, and I'm going to substitute, -2. I'm going to substitute my x value in for 3 plus 8 is equal to 4 times 3 minus 10. -2 times 3 gives me -6 plus 8 is equal to 12 minus 10. Okay? So negative 6 plus 8 gives me a positive 2, and 12 minus 10 gives me a positive 2. The answer checks out.
For today's objective, we are looking at the following. So it says, given a multi-step equation requiring the use of the distributive property and combining like terms, I will solve the equation algebraically and check my solution. All you need today is paper and a pencil. Same vocabulary terms that we've been looking at since the beginning of this week. And the same pictorial representation. So now we have officially looked at all three of these things. Today we will be focusing more on the left-hand side and solving algebraically. Yesterday we looked at modeling the multi-step equations just like in the middle. And on day one we looked at translating between verbal and algebraic expressions and equations. So we do have 4 instructional videos today for you to look at. Let's go ahead and take a look at the first one here about the distributive property.
Let's learn about the distributive property. The distributive property is a rule that helps us rewrite certain expressions. To help us learn about the distributive property, let's go ahead and start by comparing 2 expressions. Let's take a look at the first expression. 3 times the quantity 8 plus 5. Now let's go ahead and simplify this expression first before we take a look at the other expression. Well, to simplify, we follow the order of operations, and since we have parentheses, we simplify what's inside first. So we take 8 plus 5. Well, that gives us 13. Then we take 3 times 13, and that gives us 39. Great. Now, let's take a look at the other expression. The other expression we want to look at is 3 times 8 plus 3 times 5. Now, let's simplify this expression and see what we get. Well, following the order of operations, we multiply first. 3 times 8 is 24, and 3 times 5 is 15. 24 plus 15 gives us 39. Hey, that's the same thing we got when we simplified the first expression. So, both of these expressions simplify down to the same thing. That means that these expressions are equal. 3 times the quantity 8 plus 5 is the same thing as taking 3 times 8 plus 3 times 5. Now, let's go ahead and investigate what we've just found. Let's take a closer look at what's going on here. And to do that, let's bring in some variables. So let's rewrite this expression, except instead of that 8, let's put in an x. So let's now say that we have this expression, 3 times the quantity x plus 5. So here, we're taking x plus 5 3 times. Now, to help us see this visually, let's go ahead and draw this out with algebra tiles. And here we have x plus 5 written out 3 times with algebra tiles. So this is a visualization of this expression. Now, is there a way that we could reorganize these algebra tiles to maybe write this expression in a different way? Well, let's go ahead and group the like tiles together. So let's put the x's together and these singular tiles together and reorganize them that way. Well, here we would have 1, 2, 3 x's, and if we count up these tiles, that's 15 tiles. So we could also write out these same algebra tiles with the expression 3x plus 15. Well, since we've used the exact same algebra tiles, these expressions are equal. 3 times x plus 5 is the same thing as 3x plus 15. It looks like all we really did was take this 3 and multiply it by each term inside the parentheses in order to get this expression. That is what the distributive property is all about. So let's go ahead and take a look at this useful property. The distributive property states that for any real quantities A, B, and C, these statements are true. If we take A and multiply it by the quantity B plus C, the distributive property allows us to distribute in that A into each term inside the parentheses. So A times the quantity B plus C would become A times B plus A times C. And we can do this the opposite way as well. If we have B plus C first and A second, we can still take that A and distribute it into each term inside the parentheses, just like this. And this also works if we're subtracting inside the parentheses. So say we have A times B minus C. Well, with the distributive property, this would become A times B minus A times C, just bringing the sign inside the parentheses with us. And of course, this works the opposite way as well. So if we have B minus C times A, once again, we can distribute in that A, and we get B times A minus C times A. So this is the distributive property. So the distributive property can help us simplify different expressions. Let's go ahead and take a quick look at using it in an example. So let's say that we have this expression, 3y times the quantity 2x plus y. And we want to get rid of those parentheses. Well, we can using the distributive property. We can take this quantity outside of the parentheses, 3y, and distribute it into each term inside the parentheses. So we can rewrite this as 3y times 2x plus 3y times y. Then we just simplify. 3y times 2x gives us 6xy, and 3y times y gives us 3y squared. So, using the distributive property, we were able to take this expression and rewrite it without parentheses. That can be very useful when you're trying to simplify different expressions. So, now we know about the distributive property. When you're multiplying a quantity by a sum or a difference, the distributive property lets you rewrite the expression by distributing the quantity and multiplying it by each term inside the parentheses.
All right, and let's look at the second video here about solving a two-step equation.
Solve for B. In other words, what value for B will make this equation true? Let's take a look. We have some number we're calling B. We're going to multiply that number by 3, take that number, subtract 4 from it, and it needs to be equal to 11. If we want to solve for B, we need to get B all by itself. In other words, we need to isolate B. So how do we do that? Well, we need to look where B is in our equation, and we're trying to get it by itself. We're going to do so using the reverse order of operations. That means we need to worry about this minus 4 first. If we want to move this minus 4 to the other side of the equation, we need to perform the opposite operation being performed on it now. Right now, 4 is being subtracted. The opposite operation from subtraction is addition. So we need to add 4 to the left-hand side of our equation. And if we add 4 to the left-hand side of our equation, from the addition property of equality, we must also add 4 to the right-hand side of our equation. 3b minus 4 plus 4 is just 0. This is equal to 11 plus 4, or 15. So now b is slightly more isolated, but it's not all by itself. Remember, when there's no symbol in between a variable and a number, there's what's called an implied multiplication. This is the same thing as 3 times b. We're saying it's equal to 15. So we want to get b all by itself still, but we have this times 3 out front. How do we move this multiplied by 3? Well, what's the opposite operation from multiplication? It's division. So we want to divide the left-hand side of the equation by 3. And if we divide the left-hand side of the equation by 3, we must also divide the right-hand side of the equation by 3 from the division property of equality. So 3 divided by 3 is just 1. So we're just left with 1b, or b. This is equal to 15 divided by 3. 3 goes into 15 5 times. So this means that b is equal to 5. So we have a value for b. b is equal to 5. But just to make sure we didn't make any mathematical errors, it's a good idea to always check our answer. So if we want to check this answer, what we can do is we can check it in our original equation. We want to make sure when b is equal to 5 that this does in fact equal 11. So instead of writing b, we're going to write our value 5. 3 times 5 from 3 times b minus 4, and we want to know if this does in fact equal 11. Using order of operations, we need to multiply first. 3 times 5 is 15. Minus 4, and we're wondering, does this equal 11? If it does, we got the right answer. 15 minus 4 is equal to 11. Since 11 is equal to 11, that means that our answer, b is equal to 5, is the right answer. So we solved for b, and we got that b was equal to 5.
That video should have been a review. And now we're going to make sure that we look at combining like terms.
Let's solve this equation for x. Well, if we look at this equation, we can see we have two terms that contain an x. We have a negative 6x and a positive 3x. So in order to solve for x, let's start out by combining these like terms. This will make it much easier for us to solve for x. So we want to combine together negative 6x and positive 3x. To do that, we want to combine together the coefficients in front of each x. Negative 6 and positive 3. Well, negative 6 plus 3 is negative 3. So that means that negative 6x plus 3x is negative 3x. And we still have a negative 21 on the right-hand side. Now we have an equation that we can more easily solve for x. To get x by itself in this problem, all we need to do is move that negative 3 to the other side of our equation. To do that, we want to divide both sides by negative 3. In other words, we want to use the division property of equality. So we divide by 3 on both the left and right-hand sides. Our negative 3's cancel out on the left, and we're left with x. On the right, we get a value of 7. Now we've solved for x. In this case, x is equal to 7. But let's make sure and check our answer. So in step 3, we'll check our answer by plugging in the value we got for x into our original equation and seeing if it makes a true statement. So we have negative 6 times x, which we found to be 7, plus 3 times x, which again we said was 7, and we want to know if that equals negative 21. Well, negative 6 times 7 is negative 42, and 3 times 7 is 21. Does that equal negative 21? Yes, it does. Negative 42 plus 21 is negative 21. So we get a true statement. That means we did everything correctly. For this equation, x is equal to 7. Remember, if you're trying to solve an equation for a variable where you have the variable in multiple terms, first combine those like terms, then solve for your variable.
And now we have one last video to watch on solving multi-step equations using the distributive property.
Let's solve for b in this equation. Notice that we have two b's, so we need to combine them together. But before we can do that, this b is stuck inside these parentheses. So we need to get rid of these parentheses first. To do that, we're going to use the distributive property to distribute our 3 into our parentheses. So take 3 and distribute it into 23 and negative 2b. We'll get 69 minus 6b, and then we rewrite our 3b, and that equals 48. Now, our b's can be combined together. So step 2 is to simplify. When we do that, we still have our 69. We now have a negative 3b, and that equals 48. Now we can solve for b. Step 3 is to solve our problem. So take this 69 and subtract it on both sides of our equation. This will give us negative 3b equals negative 21. Then take this negative 3 that's being multiplied by b and divide it. We'll get b equals 7. So we have an answer of b equals 7. Now our last step is going to be checking our answer to make sure it's correct. So step number 4 is to plug in our answer into our original equation and see if it makes a true statement. So take 7 and plug it into any b that you find in our original equation. So we get 3 times the quantity 23 minus 2 times 7 plus 3 times 7, and we want to know if that's equal to 48. Well, let's simplify it. 3 times 23 minus 14 plus 21, is that equal to 48? I don't know. Keep simplifying. 3 times 9 plus 21, is that equal to 48? Well, 3 times 9 is 27, and 27 plus 21 is 48. And 48 equals 48. So we get a true statement. That means our answer, b equals 7, is correct.
Great. Now it's time for some independent practice. There's going to be a couple practice problems that we are going to do, and then you can check your work with our videos after. So example 1 says, what value for n makes the following sentence true? You have 2 times the quantity of n plus 3 equals 5. So remember here, you're going to have to start by doing the distributive property. Go ahead and pause the video so that you can solve and check your work. And now we can go ahead and get to the solution.
Welcome back to day 3. Let's go over example number 1. So here we're solving equations algebraically and then checking the solutions. All right. So for example number 1, here we see the distributive property. So this number 2 is going to be distributed to both the 1n and the positive 3 using the operation of multiplication. So this is 2 times n, that's 2n. And then 2 times positive 3 is a positive 6. And then I'm going to bring down my equals 5. After the distributive property, we should always be looking to see if we can combine like terms. 2n and 6 cannot be combined because they are not like terms. One has an n and one does not. From there, we're going to try to undo addition and subtraction. So here we have plus 6. The opposite is minus 6. What we do to one side of the equation, we must do to the other. All right, so here is our 0 pairs, just like we were doing yesterday with algebra tiles. So that's 0. So what's left is 2n plus 0, which is the same thing as just 2n. And that's equal to 5 minus 6, which is negative 1. All right. Then, to get that variable by itself, to isolate it, we have to figure out what's attached and undo it. So this is 2 times n. So the opposite of times 2 is divide by 2. What I do on one side, I must do on the other. 2 divided by 2 is 1. So this is 1n, or just n, equals negative 1/2. All right, so to check it, we need to plug in our solution for the variable and make sure that the left side and the right side match. All right, so we have to copy down the problem first and then plug in. So this is 2 times the quantity. We think that n is negative 1/2 plus 3 equals 5. All right, so here comes back substitution from when we were doing order of operations. So our order of operations says we must take care of what's in the parentheses first. So negative 1/2 plus 3 is 2.5. Bring down everything else we have not used. All right. 2 times 2.5 is 5. All right. So we have 5 equals 5. That is a true statement. So that means our answer is correct. N equals -1/2.
Let's move on to example 2. Example 2 says, what is the solution to the equation below? So here you're dealing with a lot of fractions. We have 5/6 p plus 1/3 p minus 1/2 equals 6 1/2. Go ahead and solve and check your work yourself. And then in just a moment, we'll move on to the solution. Go ahead and pause your video now to solve the problem. Here is our solution to question 2.
All right, let's review the solution for example number 2, and then we will check our answer. All right. So when we're solving these multi-step equations, we should always look for the distributive property first. All right, but we do not have the distributive property here. Then we always look to combine like terms if we can. So we look on the left side of the equation. Yes, I do have like terms. I have positive 5/6p and I have positive 1/3 p. Those are like terms, so we can combine them. All right. So 5/6 plus 1/3. In order to add fractions, we need common denominators. So the least common multiple between 3 and 6 is 6. So this one can stay. And we want to make this one have a denominator of 6 so we can combine them. So 3 times 2 is 6. So what will we do to the denominator? We do to the numerator. So 1 times 2 is 2. 2 6 reduces to 1/3. That's a good check to make sure that we have found an equivalent fraction correctly. I'm going to bring down what I haven't used. So we had to do one extra step there just because we did not have common denominators to combine our like terms. So now we can actually combine them. So 5/6p plus 2/6p is 7/6p. When we add fractions, we add the numerators and we keep the denominators. And we need to make sure those denominators are common. So that's 7/6p. Then we have minus 1/2 is equal to 6 1/2. All right. So we want to isolate this variable as always. So what's attached to it is the 7/6 and this 1/2. All right. The 1/2 is attached by subtraction and the 7/6 is attached by multiplication, right? That's 7/6 times p. So we're always going to undo addition and subtraction first. So the opposite of minus 1/2 is plus 1/2. What I do on one side of my equation, I must do on the other. So I'm also going to add 1/2 over here. So negative 1/2 and positive 1/2, that's a zero pair. They're opposites. So what's left is your 7/6p. And then on the right side, 6 1/2 plus 1/2 is 7 wholes. Now this is 7/6 times p, so the opposite of multiplying by 7/6 would be to divide by 7/6. What I do on one side, I need to do on the other. 7/6 divided by 7/6, when you divide a number by itself, it's 1, right? Just like 5 divided by 5 is 1. 7/6 divided by 7/6 is also 1. So that's going to be 1p, or just p, is equal to. Now to make this look a little bit better, I'm going to write it horizontally. So I have 7 divided by 7/6. All right, so let's divide those. So that's 7 over 1. We can make any integer into a fraction by putting it over 1. When we divide fractions, we do keep, change, flip. So we keep the 7, we change the division to multiplication, and we take the reciprocal of the second fraction, so that's 6/7. And then it's multiplication. When we multiply, we're going to multiply straight across. So numerator times numerator, denominator times denominator. All right, so 7 times 6, that's 42. and then 1 times 7, that's 7. So P equals 6. Or I could have canceled out the 7s, 1 in the numerator, 1 in the denominator, and I would have just had 1 times 6 and 1 times 1, right? Which is 6 over 1, which is still 6. So my answer is P equals 6. Now let's go ahead and check that. So I'm going to rewrite my problem. So the problem is 5/6 of P plus 1/3 of P minus 1/2 equals 6.5. All right. And I believe my answer is 6. P equals 6. So everywhere I see P, I'm going to substitute in a 6. So I have 5/6 of 6 plus 1/3 of 6 minus 1/2. We want to know, does that equal 6.5? All right. So 5/6 of 6. All right. You can think about that as a multiplication with the 6 over 1. All right, so again, I can cancel the 6's, and that's just 5 over 1, which is 5. Or I could do 5 times 6 is 30. 6 times 1 is 6. 30 divided by 6 is 5. So this is 5 plus 1/3 of 6. So if you take 6 things, break it into 3 pieces, in each one of those pieces, there would be 2. All right, or again, you can break it apart. 1/3 times 6 over 1. 1 times 6 is 6. 3 times 1 is 3. 6 divided by 3 is 2. Minus the 1/2 equals 6.5. All right. Then order of operations says we need to add and subtract from left to right. So 5 plus 2 is 7. Bring down everything else. And then we just have subtraction. 7 minus 1/2 is 6.5. So 6.5 equals 6.5. When the left side equals the right side, that means my solution was correct. So P equals 6 is a correct solution.
And finally, for today, we have example 3. You're going to go ahead and solve this equation here for x. Now, just a reminder, you will have to combine like terms before you are able to fully solve the problem. All right, so go ahead and pause the video, solve your equation here, check your solution, and then go ahead and head on to the next slide so that we can check your work together. Here is the solution for example 3.
All right, and for our last solution today, for our third practice problem, we have this multi-step equation to solve and check. All right, so let's go ahead and get started. First, we're always looking for the distributive property, but this problem does not have the distributive property. Then we're looking to combine like terms on each side of the equation. So if I look at the left side, I have 9x and negative 7x. So I'm going to put a triangle around those. So I have a positive 9x that can be combined with a negative 7x. And also, for another set of like terms, I have a positive 1, which can be combined with a negative 5. All right, so 9x's minus 7x's will leave you with 2x's. And a positive 1 combined with a negative 5 would make a negative 4. And then what we have on the right side, we can't combine anything over there. So that's just going to still equal negative 20. All right. From there, we're going to undo addition and subtraction. So the opposite of minus 4 is plus 4. What I do to one side, I must do to the other. Negative 4 and positive 4, that's a 0 pair. So what's left is your 2x on the left side equals negative 20 plus 4 is negative 16. To finish isolating the x is being multiplied by 2. The opposite of multiplying by 2 is dividing by 2. What I do on one side, I must do on the other. So x, remember 2 divided by 2 is 1, so this is 1x, or I can just write x, equals negative 16 divided by 2 is negative 8. Let's go ahead and check it. So we're going to rewrite the problem. And then we're going to use our substitution to plug in what we believe the answer is. So we believe it's negative 8. So this is 9. So in for x, I'm going to put in negative 8 plus 1 minus 7 times negative 8 minus 5 equals negative 20. So I plugged in negative 8 each time I saw x. 9 times negative 8 is a negative 72. Bring down the plus 1, so I'm doing the multiplication first with order of operations. Negative 7 times a negative 8 is a positive 56. Bring down the minus 5 equals negative 20. Then we need to add and subtract from left to right. So negative 72 plus 1 is negative 71. Bring down the plus 56. Minus 5 equals negative 20. Again, addition and subtraction left to right. So negative 71 plus 56 is what? Negative 15. And then we still have the minus 5 equals negative 20. And negative 15 minus 5 is negative 20. So negative 20 equals negative 20. That means my solution is correct. All right, if it helps you when you're going through this, you can always box what you're doing. So like the 9 times negative 8 became negative 72, so you know what's left over. All right, same thing here, like when you do the negative 72 plus 1, that's negative 71. That makes me realize that I still have the plus 56 and the minus 5. All right, so whether your teacher taught you that or that's a strategy that helps you to see what's left, you can try doing that as well.
Here is your practice and homework for today. Please solve the problems to the right and show and keep your work so that tomorrow when we discuss these problems at the beginning of the lesson, you will have your answers to check them. And like we tell you every time, please log in to Dreambox and complete at least one lesson. You can click the clever link here and you'll log in with your information. Thanks for joining us again today, and we hope to see you again tomorrow.